Hello, everyone, and a very warm welcome to this Hopsworks webinar about how we can transform the retail industry with artificial intelligence. Obviously, this is just one of our perspectives. We're going to do a number of these industry-focused webinars the next couple of weeks and months because we've seen a bunch of really cool new use cases and customer cases come up in 2024, and we want to share those with you in 2025. And the first of those is the retail-oriented one. So I hope you look forward to this as much as I am, because we really have some great content, right? So I'm going to dive in here. We're talking about transforming retail, and because of that, I think it's useful to kind of step back a little bit and talk a little bit about the state of the artificial intelligence industry, because obviously it's going to have an impact on many different industries, and one of those is going to be the retail industry. But let's talk a little bit about why this impact is going to be so transformative, right? So first of all, I'd like to talk about this state as a paradoxical state. The reason why is because I have found, and we have found with our customers, that the value of AI has become abundantly clear these days, right? It's quite impressive how, with the advent of tools like ChatGPT and Gemini and Claude and all of those different chat-oriented, large language models-oriented results of artificial intelligence and machine learning, we have seen a very, very clear realization that there's a lot of value to be had here. We can make our processes better, we can understand our data better, we can make better decisions with AI and machine learning, we can drive efficiency, we can drive innovation. There's a lot of value to be had here. And as a consequence, these systems are moving up the value pyramid, right? They are driving real-time operational input, and that is a fantastic piece of news, right? There's a lot of value to be had here, but at the same time, the paradox is in the fact that there's quite a bit of complexity in these systems, right? There's a lot of different tools that you have to integrate in order to bring these machine learning systems, these AI systems to life. There's a lot of engineering complexity, right? Lots of different tools and lots of different layers of processing and transformations that you need to understand. And, it's operationally quite complex, right? You need to actually operate these systems 24/7, and that's not an easy thing to do, right? So as a consequence, many of these processes that we have in order to bring these systems to life are quite complicated as well, right? There's a lot of different steps, right? You start with your enterprise data, you go into a feature engineering pipeline, you store the results of that engineering, you train a model, training pipeline, you test the model, you serve the model, and then you monitor the model. So there's a lot of different steps, which of course, we would love to automate, right? That's not trivial, right? Because as you move through these different steps, these different processes, you will find that there's a lot of different teams involved, right? So there's data engineers involved, there's data scientists involved, there's machine learning engineers involved, and of course, there's the governance and architectural oversight that needs to happen, right? And all of this, what it does is it drives up the cost. These systems have become expensive, right? You can really get magnificent results with AI these days, but they are not cheap. They are difficult to operationally deploy in lots of different ways, and as a consequence, they can be quite expensive, right? But so I think we're in this paradoxical state, right, where we all understand that an AI solution will be fantastically valuable, right? There are massive costs involved. And so we need to consider how we apply this to our business. How do we apply this to our specific environment, to our specific business use case? And that's why we want to look at specific industries. We don't want to be having a generic discussion about, what it could do for the generic case. We actually want to talk about a very specific case. We want to talk about retail in this particular case. At Hopsworks, we have seen a number of really interesting use cases that have come to life in the retail industry, right? Let's go through some of these, right? And just at a very high level, discuss what they mean for an industry. I think it's clear for the retail industry that AI has a fantastic role to play in what we've all come to understand as hyper personalization, right? When you access an online store, when you want to purchase something online at a retailer, be it for clothes, be it for books, be it for, I don't know what type of product that you might be purchasing online, then as a consumer, you almost expect the provider, the service provider, or the retail store to understand who you are and to understand what you want in near real time, right? You don't want to be looking for stuff. Actually, what you want is you want to be offered the stuff that you are looking for, right? So as a consequence, retailers are starting to use AI for hyper personalization because it allows them to segment their customer base much more accurately, right? You can group customers based on behavior and preferences, and as a consequence, provide them with much higher degree of personalization. Personalization includes recommendations, right? Suggesting products that are uniquely suited to you as an individual customer, right? So by segmenting, by personalizing, you can come up with much more accurate recommendations that have a much higher likelihood to convert in actual business, right? Another case that we have seen at Hopsworks is dynamic pricing, right? We've seen this applied in a number of different areas, be it travel, but also in, things like gaming and gambling, where pricing is adjusted based on the real-time circumstances, the real-time demand, and the real-time customer profile of the person that is accessing the retail store, right? So this is quite obvious, right? Personalization is a fantastic new opportunity, first opportunity for AI in retail. But there's another one, like for example, operationally inside a retailer, inside the business process of a retailer, you can use AI to enhance your inventory management, right? So that you can actually see, okay, based on previous patterns, based on what happened in the past and the data that we have analyzed and the patterns that we've discovered using machine learning and AI, we are now able to much more accurately forecast our demand. And of course, if we know what the demand is going to be, that allows us to optimize the entire supply chain, right? We don't need to buy stuff that we don't know has demand yet, right? And automated replenishment is part of that supply chain optimization, obviously, where you basically take stock when you need stock, not just when you think you will need stock, right? So there's a lot of optimizations possible there because AI, because machine learning allows us to much more accurately predict what we are going to need in the future. Another example is customer service. This is probably the most obvious one if you think about large language models and how they can be applied. And I don't think of, like the first generation types of chatbots and virtual assistants that we saw. There's some really bad examples out there that, we really don't want to repeat. But there are also fantastic examples of these chatbots and virtual assistants, which are all LLM-based applications, right? They are systems that have been built around large language models that basically know how to interact with voice or text provided by a client. We can do much, much more better and more efficient customer service by applying these techniques, right? We all know, if you're still handling customer service through a call center or something else like that, it's extremely costly. And all you want to do is avoid the call, right? Because the calls are so costly, you want to have less of them, right? But of course, if we can make this more efficient, if we see that, customer service has actually become not just a cost, but also an opportunity for further engagement, then why not? We would love for them to interact with us, right? These LLM-based chatbots and assistants, they also allow us to much more accurately understand what the frame of mind is, the sentiment is of the customer that is accessing these systems. So we can basically say, okay, these people, this particular customer is much more likely to purchase from us right now. Yes or no, right? And as a consequence, we can do much more, and I'm repeating myself, but much more personalized shopping experiences by looking at this understanding of the language interaction with the customer. All of this obviously needs to be done through data quality and governance, right? AI has the potential of helping us with that, of more easily integrating lots of different data sources, cleaning those data sources, validating those data sources, and at the same time understanding where it comes from and auditing everything, right? All of this will benefit from an AI culture or an AI-driven culture where we try to provide really innovative, collaborative support to the clientele of the retailer and really understand what we can do and optimize our business that way. Having said that, I think this is probably the right time to understand, how Hopsworks can help you with this, right? So we've seen that we're in a little bit of a paradoxical state. There's a lot of value to be had, but there's a lot of complexity to be dealt with. We have seen that there's a lot of transformative possibilities, specifically in the retail industry, where we can really help retail organizations seize the value of the machine learning and AI solutions. So now what we're going to do is understand how Hopsworks helps with that. How we, as a provider of infrastructure software for AI, right, we call this a lakehouse, an AI lakehouse. How do we help you get there? Let's talk about that, right? So the first thing that we're going to be doing when you start looking at Hopsworks is that when you've identified the use case, when you identified the predictions that you want to make, right? The prediction problem that you want to solve, we're going to break this down. We're going to break this down into a number of different steps, right? I've highlighted this before when I talk about all the processes and the teams that collaborate on those processes. But we're going to break this down into 3 different steps, right? A feature pipeline where we create the features and store the features. A training pipeline where we train the model and then, of course, test that model. And then an inferencing pipeline where we actually start serving the model, either in batch or in real time, and of course, verify and validate all the time whether or not the model is performing. We monitor this. Right? So you go through all of these different steps, and as you do so, you will know that different people need to be involved. Different roles inside your organization will need to collaborate on these different steps, on these different process steps, in order to solve the prediction problem, in order to bring the AI system to life. Well, that is a really complicated thing to do. Bringing all these processes and all these teams together to work with these different steps is a really complicated thing to do. And as a consequence, the way that we have opted to do this with the Hopsworks AI Lakehouse is to bring people together around the data infrastructure. That data infrastructure we call an AI Lakehouse. We bring all the data together that you need for your feature engineering, for your training, for your inferencing, so that you can solve the prediction problem, right? In an AI lakehouse, you have multiple components, right? You have features that you're going to store either internally or externally inside the system. You have views of those features where you combine them flexibly so that different projects can share features and don't need to re-engineer everything themselves all the time. You have a registry so that you can easily store the model definitions and deploy those model definitions really easily, and so that they can be shared with all the different projects. And as a consequence, you have an architecture where lots of different source systems, right, the entire analytics and enterprise data ecosystem can be brought together on this lakehouse infrastructure where you combine offline data and online data so that you can create these prediction systems. And everything is going to be looking at that central repository. The AI lakehouse, I always think of this as a forcing function for AI. It's where you bring everything together. It's where you bring the people together, where you bring the processes together, where you bring the data together, right? It's the AI lakehouse is going to be the fundamental piece of infrastructure that you need in order to avoid having a messy architecture, right? Where everyone is doing their own thing, every team is doing their own thing, right? And you really implement a unified platform for all of the different use cases. In our view, this is actually something very, very valuable. It's super valuable, not just for the engineer, right? The engineer is going to benefit from this because they don't need to re-implement everything themselves, right? They can actually leverage infrastructure that has been put in place, that has been pre-configured, and that is worry-free, right? It's highly available, it's performant, secure, it's manageable, it has all of those things to offer to the individual engineer. But it also brings efficiency to the teams, right? The managers of those teams are going to be looking at this and say, okay, that means that my individual team doesn't have to do the feature engineering themselves anymore. They can just leverage the feature that is already there, right? Which is a great idea, right? And it will drive efficiency and cut costs from these systems. Remember, when we talked about the paradoxical situation of AI these days, one of the things that we're seeing is that these systems are too costly. The total cost of ownership is too high, right? Well, we can drive that down by sharing the infrastructure. And last but not least, we all know that there's a lot of new regulations coming up, right? If we're implementing machine learning and AI, we're going to have people that want to oversee that want to make sure that there's a central point of control where everyone knows that the systems are going to be secured. Right, so this is what we provide as value with Hopsworks. And I'd like to take the time now to quickly illustrate that. So let's go into a short demo here so that you can actually see what we're doing and how we're doing this. Let's take a look, right? So what I'm going to show you here is a short demonstration of Hopsworks, but actually not the Hopsworks infrastructure alone. It's actually something that we have built together with Paul Houston. Paul is a machine learning engineer who runs a fantastic Substack. If you go to decodingml.substack.com, you will find a lot of resources here that basically explain a lot of different topics on how to develop machine learning systems. And part of that Substack, you will actually see that there are some courses here. Some of those courses are payable, I believe, but some of them are actually really, really good, and they are free, right? So I don't know why the page is not found here. I actually wanted to show you this one, which is the TikTok-like recommender system, and it's a full course. It's really, really cool to build a full-on recommender system. And I thought this was super appropriate for this retail webinar. So I'd like to show this to you. It's been out there for a couple of months, but here you basically see how Paul goes through all of the different steps of building a true recommendation system, right? So he goes through the high level concepts, as you can see over here, right? The different paradigms that we have. Maybe I should zoom out a little bit here so you can see this better, right? So he explains what the architecture is and how the architecture goes through the different steps of providing a user with a great recommendation system. And then he also explains, how the different pieces fit together, right? And you will see, it goes through all of the feature engineering, right? It goes through all of the training, right? So you can actually create the model that you want to deploy in order to provide this recommendation system. And it also goes quite far, right? So there's a simple recommendation system here based on a two-tower model, but he also integrates LLMs to make it super interesting for you to apply, like the latest techniques here, right? It uses a really great data set, which is provided by H&M. This is, it's already 3 years old, but it's still, I would say, one of the reference data sets on Kaggle for recommendation-based fashion-based recommendation systems, personalization systems. And it's actually the real thing. It's not imaginary. This is the type of thing that people will want to buy and build in a retail context. Paul has also provided you with a full end result, right? So you have a Streamlit app, which is linked from the Decoding ML pages here. But this Streamlit app, basically allows you to simulate, okay, I'm going to buy this item and I'm going to buy something else here. I'm going to look at what this is, and then I'll decide whether or not I want to buy it. Yes, let me buy that, right? So I'm building up like a history here, right? So you see that, I'm a particular client and, I have 5 purchases by now. And then you can basically say, okay, why don't we get some recommendations, right? And it will, call the model, it will call the prediction system that we have built, and it will come up with new recommendations, right? And I apologize if this takes a little bit of time, but this is usually because the recommender system is auto-scaled. It goes up and down based on the load. And it could be that at this particular point in time, there are no recommender systems running. And as a consequence, this is just a cost optimization thing, but it might take a little bit of time here. Let's see when this comes back. Yeah, as you can tell, there's a little bit of a delay here. I need to wait until the deployment is back up and running. Shouldn't take too long. So let's be a little bit patient here. Here we go. Now the system has returned a couple of recommendations here, which is great. I can also, see if everything is working, yes or no. And I can also use something which is really cool, which is using the OpenAPI LLM system, right? So I'm going to grab my OpenAPI key here and paste that over here. That's not it. I'm going to paste that in there. And then I can say, okay, I'm a male that is going for a particular winter wedding, right? And then say, okay, I'm going to generate recommendations based on how we have interpreted that particular sentence, the particular prompt, right? And it's going to come up with, some completely different recommendations, right? For, the suit or the pants or whatever, right? So there's some really sophisticated things that Paul has developed in the course. I would highly recommend that you go through this, right? Go to the Decoding ML Substack and walk through the different steps. But what I'd like to do to finish off this webinar is to show you what that looks like from the inside, right? Because as I said earlier, we are going to be using the Hopsworks AI Lakehouse to develop this system, right? So The feature engineering pipeline is going to leverage our feature store. Then the feature store is going to be used to train the model, and the model is going to get registered inside the AI lakehouse. And then we're going to deploy that and provide the prediction system based on that. So I'm looking at a Hopsworks system here, right, which obviously we have pre-configured. The first thing I'd like to show you is that we do have like the project-based sandbox mechanism. We can separate different environments from each other by implementing project concepts, right? Which means that, you know, every project has its own features, but it also has its own training data sets. It has its own models, obviously its own deployments, and you can see that over here, right? So if I go into the feature group for the time series tutorial, I have a number of feature groups here, different versions of those feature groups. I have a number of feature views, or one feature view with different versions, and then I also obviously have a model and a deployment associated with that. If I go to a different project, which is the recommender course that we've been talking about all along in this webinar, then you see that I have completely different feature groups, right? So I have customers, I have articles. This actually corresponds to the Kaggle data set that we have implemented here, right? So we've imported the data into the Hopsworks environment, right? And basically created features based on that. So customers, articles, transactions, interactions, right? Clicks, right? And then we have the rankings. You know, if we rank the different recommendations, and as a consequence, we will also have a different feature group for that. We have a feature view, right, where we combine different elements from different feature groups, right, and we combine them together. You know, we have different capabilities there, right, where you for example, here have different feature groups, right, the ranking feature group, but also the transaction feature group. All these things come together in a feature view. They're combined together, right? And then, of course, we have a way to create a model for this, right? And the model gets registered in the model registry. There's a query model, there's a candidate model, there's a ranking model. All of this is explained in detail in the course, right? And, you know, we eventually deploy that. We have a deployment where we have a K-serve deployment for querying the model and ranking the results in the model using the Hopsworks AI Lakehouse. Lots of different things you can configure here, and I won't go into the entire detail of how this works. Would like to mention that we also have compute capabilities inside Hopsworks, either based on Jupyter notebooks or jobs that you schedule or Airflow DAGs that you would schedule. We have a lot of capabilities for the full spectrum of MLOps that you want in order to implement your recommender system. So that kind of completes this short little demo. I'd like to wrap up this webinar by reiterating what we have seen here, right? So in the demo, you know, we have gone through the entire sequence of events, right? So there's a feature engineering pipeline, there's a training pipeline, there's an inferencing pipeline, right? And the result is the Streamlit app that we have quickly explored. You know, there's an entire chain of steps that you need to go through, right? So customer comes in and basically gets submitted to the customer query model, where we have candidate articles that are looked up in a vector index, so that you have candidate articles that we can start to filter. Then we submit those candidates to the article and customer feature view, so that we can rank them, right, through the ranking model, and present the user with a sorted list of recommendations, right? So that's how this entire thing works. There's a lot of different components here, but, you know, it's actually quite simple in concept, right? So you can actually make this work quite easily either on the your own Hopsworks infrastructure, if you want to run that on your own Kubernetes cluster, or you can also use our serverless Hopsworks installation on app.hopsworks.ai. So with that example, I would like to conclude this retail webinar. I think we have demonstrated that using the Hopsworks AI Lakehouse, we are able to help retail customers really get the more value from their AI implementations, which means that, you know, they can get better recommendation systems, better personalized recommendation systems. They can actually optimize their supply chains using Hopsworks. They can transform customer service by working with LLMs and really making it easier for the customer to interact with your systems. And at the same time, make sure that you have data quality and governance implemented throughout. I hope this was a useful session for you. I would warmly invite you to join our public Hopsworks Slack. Try our latest tutorials. Ask us any questions where you have anything that you would like to ask us. And then with that, I would like to thank you for attending this webinar and wish you a wonderful rest of your day. Thank you. Bye-bye.